Polynomials. Ugh. I dislike polynomial questions because I refuse to do work. I was getting pretty annoyed with all the remainder problems. Find the remainder of this, find the remainder of that. Then I learned the remainder theorem, and all my problems disappeared. The remainder theorem says, if you have the polynomial f of x, and you know that it is divisible by x minus a, then you could say x minus a times some quotient that we really do not care about, plus some remainder is equal to f of x. Alright, well, it's very hard to find out what the remainder is. What is r, right? But we do know that x minus a can be divided. X minus a times something plus r is f of x. So what if we just plugged in a so that x minus a will just turn into 0? This means we have f of a is equal to a minus a times some quotient we still do not care about, plus r, the remainder. We can simplify this. We got f of a is equal to 0 times some quotient plus r. So f of a is equal to r. Oh wow, okay, well, we know the remainder. It's f of a. So, knowing this, let's do a couple problems. Alright, find the remainder of x squared plus 3x plus 7 divided by x minus 1. Alright, well, let's write our equation. F of x is equal to x squared plus 3x plus 7. Now, looking at the remainder theorem, we know that f of x is equal to x minus 1 times some stuff we really don't care about, plus some remainder. Now, if we plug in 1, x minus 1 will become 0. So, f of 1 is equal to r. So now we can just plug in 1 into x squared plus 3x plus 7. This becomes, I'll write it down here. This is equal to 1 plus 3 plus 7, which is equal to 11. Therefore, the remainder is 11. Let's move on to another example. Find the remainder of x cubed plus 4x squared plus 7x plus 9 divided by x plus 2. This looks nasty, but let's do the same thing. F of x is equal to x cubed plus 4x squared plus 7x plus 9. So let's write this as remainder theorem again. F of x is equal to x plus 2 times some stuff we don't care about plus r. Okay, well, we'll just plug in negative 2 because we know that f of negative 2 is equal to r. So this is equal to negative 8 plus 4 times negative 2 squared, which is 16, plus 7 times negative 2, which is minus 14, plus 9. And this simplifies to, this negative 8 plus 16 just becomes positive 8. And minus 14 plus 9 becomes minus 5. So r is equal to 3. Now let's move on to our last example. This looks dirty. 3x to the power of 4 plus 2x to the power of 3 plus x squared plus x plus 3. Alright, well, f of x is equal to 3x to the power of 4 plus 2x to the power of 3 plus x squared plus x plus 3. Alright, well, let's write this as remainder theorem. f of x is equal to x minus 3 times some stuff we don't care about plus some r, remainder. We can plug in 3 and we get f of 3 is equal to r. Now if we plug in 3, we get 3 times x to the power 4, so 3 times 3 to the power 4, which is 3 times 81, plus 2 times x to the power 3. X to the power 3 is 27, so 2 times 27, plus x squared, which is just 9, plus x, which is 3, and plus our constant, which is 3. This becomes 3 times 81, that's just 243, plus 2 times 27, that's just 54, plus 9, plus 3, plus 3, and this is equal to, well, 243 plus 54 is 297, and 9 plus 3 plus 3 is just 9 plus 6, which is 15. So 297 plus 15 is equal to 312. So R is equal to 312. Alright, so remainder theorem might look a bit complicated at first, but really all it is just plugging in a number and just canceling out stuff that you really don't need to care about.